The last colligative property is osmotic pressure. What is osmotic pressure? I will explain in detail about the osmosis, but this time we are discussing osmotic pressure. So, more the number of solutes provided to the solution, more the osmosis so as to osmotic pressure. More the number of solutes, I mean more the concentration of the solutes, more the osmosis, as such more the osmotic pressure. Mathematically, it is denoted by pi, and pi is directly proportional to the concentration, and so pi is directly proportional to the concentration and temperature. So you remember it, pi is equal to R into C into T. We have done in 11th class. R is the solution gaseous constant. Here R is the solution constant. R is solution constant. At 1 atmospheric bar, it is 0.0821 liter atmosphere, Kelvin inverse, mole inverse, right? And in Pascal, 8.314 joule, Kelvin inverse and mole inverse. It is the concentration and this is the temperature. So what is the concentration? Concentration, you know it very well. Number of moles per unit volume, right? Once you calculate the number of moles, so the equation can also be written as R into N by V into T. Since we know the N number of moles of solute, WB upon MB, given mass upon molar mass. That's why I put these values. Pi is equal to R into WB upon MB into volume into T. Knowing all the parameters, osmotic pressure can be calculated. R provided already constant, given mass of solute, temperature given in degree Celsius, you may change into Kelvin. If it is given 27 degrees Celsius, what about in Kelvin? 310. If it is given 37 degrees Celsius, 310 Kelvin. And then you can calculate what is this? You can calculate molar mass of non-volatile solute. And see, once again we have proved pi is one of the important colligative properties. Therefore, it is inversely proportional to the molar mass of non-volatile solute. Question usually asked in CBSE paper many times, why is osmotic pressure method? Why is osmotic pressure method considered as better method to calculate the molar mass of proteins, or you can say bio molecules or polymers, because they possess more large molecular mass. For such kind of substances, you don't consider the elevation in boiling point and depression in freezing point. Anyone tell me? Because you know in elevation in boiling point, temperature is very important. Now, so more the temperature, dissociation of the biomolecules take place. Secondly, in depression in freezing point, see, lesser the temperature, coagulation may occur, which is known as denaturation of protein. As such, this biomolecule mass can be calculated by taking osmotic pressure, because of since biomolecules are highly unstable at cooking temperature. So as such osmotic pressure method is applied because it takes place at room temperature. And in another way you can say, in rest of the qualitative properties, the value will be very negligible. That is why here at least we can get a reasonable values, that is molar mass of protein and all that. Protein, biomolecules, DNA, whatsoever it is, or polymer. So only osmotic pressure method is applied to calculate the molar mass of non-volatile solute like polymers, proteins and whatever it is. Biomolecules especially. So this is all about, say, the points which I have already explained you. Concentration of the solution, everybody has done in 11th class. Then relative loading of vapor pressure. Then you can say Henry law, effects of pressure. Then Rhodes law for volatile and non-volatile solute. Then types of the solution, ideal and non-ideal solution, and non-ideal solution showing two types of the deviation, which is the positive and negative deviation. After that, important parameter of this unit is qualitative property. There are 4 qualitative properties: relative loading of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. Questions pertaining to all these I have already explained here during my discussion. If you find any difficulties, let me discuss on phone and I can satisfy your queries regarding qualitative properties and any other question. In my next class, we will discuss osmosis, reverse osmosis, and Van't Hoff factor, including abnormal molar mass. Thank you. Have a nice day. Dear students, good morning once again. And the next part is the osmosis. Osmosis is defined as the spontaneous movement of solvent molecule from lower concentration to higher concentration through a semi-permeable membrane is called osmosis. What is semi-permeable membrane? The membrane which can allow to pass the solvent molecule from lower concentration to higher concentration. Especially you have taken a dilute solution or aqueous solution. In that term, from the chemistry points of view, I have explained the osmosis. And then osmosis is different from the diffusion, because osmosis is the property of the solution, liquid, but diffusion is the property of the gases. Diffusion does not require semi-permeable membrane, but osmosis requires semi-permeable membrane. Then the example of the semi-permeable membrane are, cellophane, parchment paper, cell wall, pig's bladder, egg lining, etc. The very important, and cellulose acetate also, you can write here, cellulose acetate. And the artificial semi-permeable membrane, that's very important, is the K4 FeCN6. How do you get this compound? It is a complex compound, man-made semi-permeable membrane, that you can get K4 FeCN6 plus CuSO4. So CuSO4 plus CuSO4 plus SO4 plus K4 FeCN6. Now it becomes, now CuSO4 plus K4 FeCN6. 2 CuSO4, that is the Cu2 FeCN6 plus 2K2SO4. Actually, this is the artificial semi-permeable membrane. So you correct the equations now. Whenever copper sulfate reacts with potassium hexacyanoferrate to give copper hexacyanoferrate, and byproduct is the potassium sulfate. So the way you can calculate the, we can get artificial semi-permeable membrane. So based on this semi-permeable membrane, solution is of 3 types. Solutions are of 3 types. First is the isotonic solution. Second is the hypertonic. Third is the hypotonic solution. As the meaning of the isotonic, when the concentration of the 2 substances will remain same, is called isotonic. In that case, no osmosis takes place, because osmosis means the movement of the solvent molecule from lower concentration to higher concentration. And tell me the example of the osmosis, that is the germination of seeds, germination of seeds, flowering of plants, swelling of the resins in water, and movement of leaves are the examples of the, you can see, osmosis. And so far as isotonic solution is concerned, blood is, RBC is isotonic with 0.91% weight by volume of NaCl, or 5% weight by volume of, what is that? Sugar. This is called saline water, and this one is called glucose water. So 5% weight by volume and 0.91% weight by volume. In that case, no osmosis takes place. And B case is hypertonic. Out of the 2 components, 2 substances, if the concentration of one is greater than the other, then it is called hypertonic. For example, you can say, by taking one example here, when RBC is placed in, RBC placed in 1% NaCl solution, that is called as brine solution. It is known as aqueous solution of sodium chloride is the brine solution. Then tell me, what about the osmosis? So since the concentration of NaCl is more than the RBC, so RBC, the liquid molecule will come out from the RBC. It is called X osmosis, and osmosis takes place, and in that case RBC will, what is that? Shrink. So here, which is hypertonic, which is hypotonic? NaCl solution is hyper, and RBC is, what is that? Hypo. If the water molecule or the liquid will come out from the substances, it is called X osmosis. When RBC is placed in 1% NaCl, then shrink will take place. And just opposite to the hypotonic. What do you mean the term hypotonic? If the concentration of one component is lesser than the other. For example, when RBC is placed in 0.85% NaCl weight by volume, then it is known as hypo, and RBC is known as, what is there? Hyper. So water molecule will enter in the RBC, and RBC will swell and burst. So this is the hypotonic. So isotonic, hypertonic and hypotonic. You consider all these three and solve questions based on these three from textbook. Then why is a special care taken by doctor before intravenous injection to patient? Why? A special care should be taken by a physician before the intravenous injection by a doctor to the patient. Why? Because of, in case of hyper or in case of hypo, in both these cases RBC will either swell or shrink. Therefore, to maintain the what pressure? Osmotic pressure, so that no osmosis occurs, because in hyper or hypo, RBC may shrink or swell. Both these conditions are harmful to patients. That is why it is suggested that doctors should take the special care before intravenous injection to the patient. This is all about osmosis and the various phenomena of osmosis and important question pertaining to the osmosis. In my next class, I will discuss Van Hoff factor. Thank you very much.